Welcome to the Wired to Hunt podcast, home of the modern whitetail hunter. And now, your host, Mark Kenyon.
Welcome to the Wired to Hunt podcast. I'm your guest host, Tony Peterson, and today I'm speaking with deer biologist Brad Cohen. All right, folks, welcome to the Wired to Hunt podcast, which is brought to you by First Light. You might notice that this is not the voice of Mark Kenyon. He sent me an email last week and said that he picked up a new hobby, which is learning fictional languages. And he's off to a convention in Omaha to really become, and this is his words, not mine, fluent in Wookiee. That's no joke, and I don't know what it means. And at this point, I'm too scared to ask. So anyway, today I'm speaking with Bradley Cohen, who is a deer biologist and a researcher. Cohen is also a passionate bow hunter, and he happens to be an expert on deer vision. He's responsible for developing and seeing through one of the most comprehensive studies on deer vision that exists. His findings, which we discuss in detail throughout this episode, are fascinating, and some of them will directly help you become a better deer hunter. Plus, it's just really interesting stuff to learn about our favorite game animal. Brad, welcome to the Wired to Hunt podcast, man.
Hey, good to be here, Tony.
You come highly recommended from our very own Patrick Durkin, and I told Pat that I was looking for somebody who was an expert in deer vision, and he said there's only one place you got to go for this. And so I really appreciate you taking some time to talk with me today on whitetails and what they really see and what you've learned about that.
Yeah, man. Anything I can do to help share the information we have and the science we do, I'm happy to be part of it.
So can you just, before we dive into this, can you give the listeners just a breakdown of where you're doing your research, what you're doing, how you got into it a little bit?
Right. So I originally am from New York, and then I got a master's degree at the University of Georgia, working under Carl Miller and Bob Warren. And as part of that research, we started to examine deer vision a little bit more into what colors can they see. And a lot of it was focused on getting a behavioral measure, or having them basically tell us in their own unique deer way what colors they could see. And then I stayed at University of Georgia working on deer during my PhD, doing something completely different. But during that time, we had several other students coming through working on deer vision, and I oversaw that research. So basically, we've done, in total, I've been part of about 4 studies focused on deer vision, anything from their color to their visual or color sensitivity, their visual acuity to their movement sensitivity.
So let's back up a second here. Out of all the stuff that you could study out there, how did you settle on, how did this become a relevant topic of research?
So let me back up a little bit more and just tell you that when I got my undergrad degree from a general biology program in upstate New York, and I went to this college. It was called SUNY Geneseo, and I went there because it was right next to my hunting spot that I grew up deer hunting my whole life. So hunting's always kind of been a big central role in my life, and I actually just put into Google Scholar the word deer, and Carl Miller came up, and that's how I kind of met him. But when I went down there, my degrees were actually, I got biology or bachelor degrees in biology and psychology. All right. So that's going to be important when we talk about how I understood how to kind of get these measures. But we went down there and had a unique opportunity. Most students that come into the wildlife profession, they get money from a grant, and that granting agency typically has specific objectives. I want this, this, and this done. Well, I was on money that was basically left over from the project. There was a pot of money, and there was no direct deliverables to be associated. And I was so lucky in that Dr. Warren and Dr. Miller were just like, let's talk about some of the things we don't understand about deer biology. Now, in this case, the money was coming from the Georgia Department of Transportation, which it's kind of weird to think about that, but they were interested in deer vision from the sake of how can we build mitigation devices to get deer off the road. And some of that comes back to just basic biology of deer. And so the world was my oyster. I kind of had the experience to understand this was a cool study, and the funding agency had the want to know, and we just took off from there.
So you kind of lucked into sort of an open lane there with that money already being there, and This was driven by, I'm assuming the DOT was looking at this going, how do we prevent vehicle collisions with deer? And you thought, well, we've tried the little whistlers on the bumper. We've tried some, oral AURAL methods, but you're like, well, how do we make something that's a visual deterrent to them?
Yeah. So like the Georgia Department of Transportation been funding research for a little bit of time, trying to be like, what do fences do to deer behavior? Well, it just creates a little hot spot where they can cross the fence on the front and back end of it. Hey, do deer whistles work? Do roadside reflectors work? And the answer was always no, they don't work. They don't work. And because it's not based on deer biology. So the Georgia Department of Transportation said, hold on, let's take it a step back. Let's tell us what deer can see, what they can hear. And then let us kind of work with you to design these devices that would mitigate it. In this case, it was, and we wanted to understand things like, how does deer vision affect the deer in the headlight look, right? So one of the applications of our research was working towards building a better headlight that would be less bright to a deer, but similar brightness to you and I. So they don't get like, oh my God, they don't know cars there. They just know that something very bright is coming at them. And so that's kind of the application that Georgia Department of Transportation was in. But then being the wildlife biologists and hunters that we are, we're always thinking about, okay, what are the other applications?
So you looked at this and you said, this is a perfect opportunity. And then I'm assuming as soon as this opportunity came up, you looked to see what other studies had been done. And you saw there was kind of a pretty big gap there in our understanding of deer vision.
It's kind of stunning when you think about one of the most well-studied animals in the world, and yet how little we understood about their just basic biology. What do they hear? What do they see? All of that. And typically it's because the people that study deer tend to be more application minded. We're always trying to say, okay, let's go out and study them in their natural environment, and then we'll make hypotheses based on that. And coming from that general biology background, I was more interested in okay, well, let's go back to the physiology point of view, and then we can project out to why they act like they do.
Yeah, so you had a unique opportunity to use pen raised deer and design it looked like almost like a Pavlovian path toward training deer and then using that food reward training to start to figure out their vision. So before we get into the design of that study, when you were like, all right, I'm going to do this, or you were really kicking this around, you're talking to Carl Miller and a couple other people. Did you kind of have it in your mind where you like, I think I know how deer see, or was there like a basic biological understanding of the rods and cones and the design of a deer's eye so you went into it and you like, I think I got this already, or not really? So
back about, don't quote me on it, maybe 20 years before that, Jay Knights and a bunch of other research. Now, Jay Knights is an interesting character in and of himself. He's now at the University of Washington and is like the expert on animal vision. He single-handedly is like working to cure color blindness in humans, working with monkeys. I mean, the guy's like way above my pay grade, but he had actually come to the University of Georgia about 20 years before that and basically done a study where you simply hook up electrodes to an animal's head and you flicker lights in their eye. And you're looking for an electrical signal pulsing from the retina. Every time you pulse a light, you get that signal, that cellular signal. And from that, we can at least tell how many cones an animal has, and cones are what seeks color. Do we have rods, which are basically the more light sensitive, black and white type photoreceptors? And then also, like, what are the peak sensitivities of those cones and rods? So he already had laid that out, but you have to understand, oftentimes that cellular response isn't always the same way that an animal perceives it. Because in the truth, perception is both mediated by the cellular responses of your retina or something like that, but also your brain, right? And, for example, you and I, if we just looked at our cellular responses, we'd be very sensitive to blue. But the truth is, we have so many different ways we inhibit blue from being perceived by us, and that we are very poor at perceiving any type of blue color. But that same type of study, just looking at the cellular, would say, hey, we can see it pretty well. So there's often this disconnect, which that's where we were going was, okay, we have some guesstimate on what we think the colors they might be able to see, but we need a behavioral confirmation. We need them to tell us that they're perceiving this color in real life so that we know, hey, they see it. Does that make sense?
Yeah. So essentially, before your study, you could kind of say, okay, this is the spectrum they can see. These are the colors they're picking up.
We hope.
Yeah, well, okay. It appears that way, but that's as far as it goes, right? Like you don't know to what degree, and you don't know what that means to them.
Right. Bingo.
Yeah.
Bingo.
And so what did you do with that? You said, that's not enough, dude. Let's dive deeper.
Yeah. So we had tried to train. I was like, listen, I think we can train deer to respond to light. In other words, it's just a classic Pavlovian dog type experiment where we're going to say, hey, there's two troughs with a treat. One of them is going to allow you to have access to the treat, and it's going to have a light on over it. The other trough will still have the treat, but if you try and approach it, it's going to shut the doors and you're not going to get that treat at all. I said, it's actually in psychology called a Skinner box. It's a super basic way we train animals. And to be honest, I remember very distinctly Carl Miller kind of laughing it off because we had tried to train deer before. And when you're hand raising deer, and because these have to be tamed deer, and you're trying to do this in a non-automated way, it's impossible. You can't get the control that you need, the number of repetitions that you need. I think the student before me, took 15 deer home and raised them by themselves, only to have one that even kind of could do an experiment with vision. And so the first thing was could we even get this to work? Would the deer understand that if we presented them two troughs to eat out of, both with the treat, but only to approach the trough with the light on, just a bright light, would they go to it? And boom, we did it automated. I had to learn computer language. It was fun, but I never want to do it again. But by the end of it, we had shown very clearly, at least with one deer, hey, we can at least train a deer to respond to a light being on. Does that make sense?
So the first hurdle that you bumped into was just that people thought you wouldn't be able to train deer for a measured response?
Yeah, it was very difficult prior to getting the type of technology that you needed to automate the process. And basically all I did, along with David Osborne, who's a research coordinator at the University of Georgia, is we worked actually with what we call the instrument shop at the University of Georgia. These are people that make fancy instruments for specific purposes. And they made an entire set of devices that allowed us to automate the process entirely. I would hit a button on my computer that says start, and then I'd show up 2 days later to collect the data. And during those 2 days, I didn't have to be there, but the deer was constantly being trained on these series of trials where the troughs open up, the treat's there, the light turns on. If the deer picks the lit trough, you get to eat the treat. If you don't, it closes. And very quickly, within a couple of days, that first deer learned, okay, I'm going to approach the lit trough. And then it was off to the races, so to say.
How long did it take those deer to start figuring that out?
Generally, we were able to train them within a week to 2 weeks. So, and that means that they were going to the trough with the light on over it over 80% of the time very quickly. Now, for animals, that's pretty good. You and I would have figured out in minutes. For an animal to do it in about a 2 week span was pretty impressive.
Yeah, I mean, I work in the dog space a lot and train dogs a lot, and it's just, people will argue whether treat training is valuable for puppies or not. I'm like, so valuable and so easy, and that's an animal that's been bred to work with us. So you get the eye contact and you have some benefits over deer in multiple different ways. But so you looked at this, and did you do this first stage just as a proof of concepts?
Yeah, no, 100%. It was a proof of concept. We came together as a group and kind of said, okay, we've got a little bit of money that we're willing to put towards this device. And they gave us the green light Dr. Miller in particular was skeptical about the idea of it. And he's like, okay, not in a bad way, just prove it to me. And when we proved it, it was all thumbs up, let's go. This is great.
So what did you do from there?
We wound up training a total of 7 deer. So to the same process.
And they were all adult does, right?
All adult does. And the reason is, let me just tell you why we choose does versus bucks. We had tame bucks. But the thing is that bucks during the rut, or just most of the time, they're angry. And when they're tamed, they're dangerous because they see you as just another deer. So they'll happily attack every single thing that's around. So females, a lot easier to work with.
Yeah. And there was no reason to believe that would bias the results at all, right?
No, not at all.
Okay.
No, there's really no difference across sexes in animals as far as what they can see or can't see. So we train them to that, and then we worked with Energizer to get very, very specific wavelength LEDs. Now this is where it kind of gets interesting. So you get these LEDs and their specific wavelengths. Like, it's not just like this is a blue color. It's like this is a wavelength in the blue color. And we started off, the light starts off as intense as possible, very bright. And we train, and the deer instantly adapt. They're like, oh, it's not a bright white light anymore. It's a bright blue light. And so they start to actually train to that. And then once you get them completely good to go, then you start to actually have the intensity, because your ability to see something of a color, right, isn't just the wavelength or the color itself. It's the intensity at which it's being presented to you, if that makes sense, right? Mm-hmm. And so we had the intensities until basically they were performing at chance. In other words, they stopped being able to see the light, and they were just randomly approaching the trough because they couldn't see it. And so we did that for a bunch of different wavelengths of light, both in the blue wavelength, which is like in the 400 nanometers, which doesn't matter for here, but in the short wavelength, and the long wavelength, which is the reds.
And what did you start to find?
I was fascinated. So with deer were able to see blue much better than we can. Typically something like 20 times enhanced sensitivity to blue colors than we have. So there were times when I was testing blue wavelengths where I couldn't see that the light was on, but the deer could. And on the other side of it is they could not see reds hardly at all, very low sensitivity to reds. And so what it did is enable us to confirm those kind of previous anatomical or physiological measurements. And now we can go from there to figure out, okay, this is how a deer perceives its world.
So there, before you did this, there was the suspicion that this is what it was going to show, that they were very sensitive to blues and not reds.
Mm-hmm. Yeah, so that's what we thought would probably, that was what the anatomical measures had suggested.
So what surprised you about it then? Was it like the degree at which they could see the blues?
So the degree, it wasn't just like, okay, actually seeing it play out by your own experience, just how different the sensitivity is, but also we expected subtle or quite large differences actually in the anatomical structure or the anatomical measurements versus the behavioral measurements, because time and time again, that's what we see in the animal world. But in this case, they almost overlapped perfectly. So whatever is going on in the cells is being transferred perfectly to the brain. It's like a beautiful synchrony, and there's no like for us, our lenses clean up a lot of light. Like they get rid of a bunch of different light that you and I would otherwise process. For a deer, that's clearly not the case. You see where I'm going with this was there was almost no difference. And so now we have a really clear sense of what they can see.
Can you explain that further? Like, how do you, well, first off, how do you know that? Like, how did this show that was that clear to them?
Oh, okay. All right. So let me back up a little bit here, and I don't want to go in the weeds. So if I go too much into it, just play with me here and say, okay, that's enough. But you get these measures, all right? So you actually have the intensity of light that they no longer can see, right, at each wavelength. Then there is a crazy equation that has 23 different variables. Don't ask me to understand them or explain them, but it has 23 different variables, and you input the data we collected, which is literally this wavelength at this intensity. You just basically track that over time, and it spits out a beautiful curve, okay? And these curves are basically curves for your actual true sensitivity to different wavelengths of light. And so we're taking our real data and taking what we understand about how photoreceptors actually work, and we're projecting that onto this kind of sensitivity graph. Does that make sense?
Sort of. You got to remember, I write squirrel hunting articles for a living, so this is this is heavy stuff. But
trust me, I'm not. Yeah, I don't mean to make it that heavy, and it's still heavy stuff for me. I mean, there's a lot of stuff that a lot of heavy lifting that occurred behind the scenes with Dr. Knights and all those people. You know what I'm saying?
Well, I love it. So you start to figure this out, and by having the wavelengths, you start to go, okay, we know where the limits are on there. We know what the deer's range, and you didn't see any variance in those 7 deer that were the test subjects. They all were consistent across each deer.
Yeah. So deer were remarkably similar. And, there's always variation, right? There's some that are more trainable than others. You always get the one deer that's the exceptional performer. You get the one that's like kind of dumb, but they were pretty similar. And then we go, okay, well, this is the actual limits. We understand the outer limits on both sides, from the reds to the blues. And we understand now, okay, based on how we measured it, they definitely only have 2 cones. They definitely have their cones peaked at these wavelengths. And we understand now what the different colors they can see, how the different intensities of those colors interplay. We can lay out it almost with with precision how at least a color world looks to deer.
So let's talk about that. Where like evolutionary wise, where's the benefit to seeing those blues so vividly and not seeing the reds?
Well, all right, let's back up a second here and just understand that deer do not perceive their world anything similar to like how we do, especially with colors. But what you have to understand is that deer are very sensitive to blue colors, which we are not sensitive to. Deer are not sensitive to red colors, which you and I are more sensitive to. So the blue coloration, being sensitive to that, makes a lot of sense from kind of an evolutionary perspective, if only because if you look at the light that's available during sunset and sunrise, a lot of that is actually in the blue spectrum. So here's the crazy thing. I want you to sit back and think, when you're sitting there 30 minutes prior to sunset and that just twinge of twilight's coming over or on sunrise, right? Just a little bit, that world is lit up for a deer. But because you and I don't see blues very well, it's dark to us. I don't know. That's kind of crazy to think, right? But our lack of sensitivity to the light that's most available during sunrise and sunset is why it's dark to us, and theoretically why deer are most sensitive to it, because it's the light that's available when they move the most.
This is going to be a crazy. Mark, the host of this podcast, recommended a book about what was it called? It was about evolutionary biology on islands. I can't remember the technical term for it, but in that book there was some examples of studying baboons and some other primates, and how it tied loosely to us being so, so reliant on daylight and so scared of nighttime predators that our eyes evolved for lots of daylight coming in, because that's when we're most active and we have to get our stuff done before the things that eat us come out at night. And what you're saying is deer, because their primary movement periods are first and last light, their eyes have evolved, or their vision has evolved to take advantage of the wavelengths that are most popular then, or the most
bingo, what most available then. So in times of perceived darkness for us and other predators, right, before nighttime and before not peak daytime, deer see a well-lit environment where they can easily distinguish predators, no problem.
Okay. So then let me ask you this. If that's the case, or that is the case, how does that tie into their ability to see it at night in the dark?
So that's a little bit different. That's an anatomical feature of their eye. They have what's called a tapetum lucidum, which is basically nothing more than a reflective lens on the back end. You know that, like when you spotlight deer and their eyes glow, that's actually the light being reflected back into their retina. So it hits their retina and goes out and then gets reflected back. So what they're doing is they're supersizing the amount of light that's there. So they're super efficient about gathering light. So while things might be in absolute darkness to us, it's actually a little more lit to a deer. So that's how they're able to see it at nighttime so well, is that they're able to more efficiently harness, for lack of a better word, available light.
So that's, that sort of just plays off of like, we just launched that James Webb telescope into space, and it's got it's got mirrors on it that are the size of a tennis court to be able to look, at light that was created 13 billion years ago. This is a mini version of just bouncing light back and forth and taking advantage of it.
Man, I'll tell you what, it's the coolest part about being in this field is the crazy stuff that you learn about how critters have adapted to live in their environment. But that's exactly what they're doing. It's nothing more than a reflective mirror to get more light at nighttime.
Is that
because we don't move during night?
Well, sure. I mean, is that consistent across all? You see raccoons, the same thing. Walleyes, same thing. That's what that is.
All nocturnal. Any animal that has some kind of peak activity at night. Most animals tend to have that kind of feature. It goes by a bunch of different names, but yeah, a reflective layer in their eye.
Is there some kind of loss in their ability in the daylight because of that? Then, like in bright daylight, because I know there is with the blue light to some extent, right? But also, that ability to harness that much light when it's dark to us. Is there a sacrifice on the daylight side?
Not necessarily. All they do is similar to us. They just contract their lens and everything real tight. So if you actually look at the pupil of a deer's eye during the daytime, it'll be really small. But during night, that sucker's huge. So basically all they're doing is controlling the amount of light that's coming in during the daytime by just letting a very little amount of light come in, if that makes sense.
Do they have a greater degree of dilation that they can do with their pupils than us? It's quite a bit bigger, right?
Yeah, yep. Yeah, and they also have a slit eye, so they have more surface area that they're exposing to their eye as they dilate. So as they constrict, they're basically they're lessening to a much larger extent than yours and eye would be.
All right. So what does this knowledge do for us as hunters? I know everybody's listening to this. Like, all right, getting past this. Like, what color should I be wearing out there? What should I be aware of? Just color wise, not movement yet, because I want to talk about movement.
You don't want me to jump into movement? Well, don't wear blue jeans or any of that stuff. And you got on. All right, so you've already made me go like way down the rabbit hole here. God Almighty, there were some technical terms thrown out there, but let me just tell you this: you got to understand that like they only have 2 cones, and as surface value, I don't think it's easy to appreciate what that means. But we have 3 cones, and it means that we can see about 1 million variations in color, subtle variations, right? Deer, just by having one less cone, it means that they see much less variations in color. They basically only see yellow into a yellowish green color and blue. That's it. So your red is yellow, your orange is yellow, your blue is blue. When you start to think about how everything we see out there for even just something like camo is, a variation of green and brown and all this, and then you kind of throw that into how a deer sees it, it's all just the same yellow. Like, you're basically in a lot of different camo patterns, one glorious big blob of yellow. And we'll explain why that really probably doesn't matter all that much when you go to movement.
So is this when I started hunting and, you can kind of follow the evolution of camo patterns to some extent. For a while, there was a huge push for photorealistic elements, right? Like, how do you take a high resolution image of the woods or the leaves or the oak leaves or whatever, get it right on a shirt or a jacket, whatever, and it looks just like that. And we've sort of moved beyond that to these abstract, jumbled kind of shading. Is that a direct response to what we've learned about deer vision?
No, it's the camouflage world is simply just what people think is cool in the moment.
It's just sales.
In the gear. Yeah, I mean, it's all sales. I mean, but, not to say that like Sitka type gears aren't based on some biology. They certainly are. Like, they worked with Jay Knights to come up with that pattern. But there's a couple things to understand. Let me just continue with this one thing. All right, so everything's kind of green. And then also when deer are most active, sunrise and sunset, there are a lot of blues in the environment. Well, I've done spectral reflectance patterning on a lot of different camo patterns. Any type of white color, just through the dyeing process that camouflage companies use, a deer would perceive that as blue. The other thing is so you have a bunch of blue stuff. And then also definitely don't use any type of detergents with the typical detergents you guys would use, because there are like UV or blue enhancers in there that you and I don't see as blue because we can't see it. It just brightens our shirts. Deer would see that as certainly some kind of bluish hue or coloration. So all that comes together. Like if you looked at my camo, so like I made a camo way back when after I did this, and I kind of just use subtle variations of that. Like I just make my own camo nowadays and it doesn't look like anything you've ever seen. It's got a ton of different colors on it. It's got different brightnesses, and it's all related to also like I just bow hunt. So like it's also related to decreasing my movements, but it doesn't look like anything that's out there because most of what's out there is literally just based on making it look cool so hunters buy it.
Have you ever, I'm sure you have, paid attention to, the fishing industry, and there's very similar arguments for fishing lures as well. And the colors that they think that, bass can see, for example, like they see orange really well, they think, and red disappears pretty quickly underwater, and and it's made to catch it made to catch, your dollars and not fish necessarily. But is there any benefit then, to, the new wave of patterns that you see out there?
Yeah, I think they're a little bit more efficient and kind of, they'll talk about this macro pattern versus micro pattern. And that's fancy words for saying big blobs versus small blobs. And the bigger blobs do tend to be like more differentiated. But yeah, you're 100% right. It's all about, and this isn't a bad thing, right? A lot of people are trying to do their best, but it's like, chartreuse lures. My favorite lure in the world to use is chartreuse. And I found out like 2 years ago that bass can't even see that color. I'm like, so this is just some kind of variation of silver to them.
Yep.
It's all a matter of like, you're selling the people on what they want to wear.
Well, isn't there sort of a kind of like a who cares, component to this? Because we know, I was just writing a piece about getting turkeys to shock gobble, and, lately, especially Michael Chamberlain's been out talking about turkeys a lot. I'm actually going to have him on one of these episodes too, and talking about how, we're reversing the order of turkeys, right? When we go out and call a bird in, a long-beard in or a tom, whatever, we're kind of like reversing what nature has, designed this to do. But at the same time, thousands and thousands of turkeys are killed that way. So part of it is like it's just an academic exercise when we can go out and I can call in turkeys and go, well, this one didn't follow the rules and that one didn't. And we know that the camo patterns that we use, regardless of what deer see, we still kill a lot of them wearing them.
It's all right. I'm a big turkey hunter, big duck hunter, big deer hunter. When you hunt, it's not just enough to be like, okay, I've killed a deer. You know what haunts you is that one time that big deer came in and busted you. And that's the stuff as hunters that we obsess over. It's those little variations of like, I shouldn't have moved. Why did I stand so early? Why didn't I find a better background? All of these things. So yeah, in the end, I think hunting has evolved into like, we know 99% of what works, right? It's all these little things that we want to find out to make it better because we're obsessive and it's our hobby. And when we think of it that way, then maybe it does matter when you're talking about just trying to tinker with things. But overall, no. You know what? People could walk around in blue jeans and a white shirt and shoot the crap out of deer anyway,
Well, isn't there some level of a benefit too from the materials that are used? Is it like a softer material better as far as light reflection or not?
So there's different types of materials that so the materials themselves, and don't quote me on everything here, but basically there's different materials go through different processing on the front end to basically how they're going to be colored white before they're actually camouflaged. And you can, in that process, ingrain these UV brighteners into the fabric. Okay, and those are going to be a little stiffer to the touch. They're going to be a little bit harder, but they're going to last longer. They're going to be brighter longer. And that's why everyone kind of went that way originally, was like, okay, we're making a better quality product, but certainly to a hunter, they're less comfortable, and to a deer, they're more visibly blue. And so now they've kind of switched the other way around, which is a different dyeing process that cuts down on that, makes it more supple.
Got it. All right, let's move on from deer colors. What are we? I think this might be more important, and correct me if I'm wrong here, but what did we learn about deer vision as far as catch and movement?
All right, let me start off with something. First, let me cover that movements related to also their visual acuity, or basically like how you and I have 20/20 vision. All right, you got to understand that like deer have about 2100 vision, so everything's blurry to them. All right, so when you think about everything being blurry to them, what they're trying to pick up on is a blob that moves around. Okay, this is important to understand because it also comes back to camouflage and being one big blob. If you think about what their whole job in life is to basically see that predator on the horizon or see them in the woods, and it's just a blob moving around, detect them, and haul. There's a couple things you got to understand. Deer's eyes don't overlap that well, so they don't have good depth perception, but they have a really good field of view. And the way their rods are kind of spaced out across their eyes, they can pick up detection like that. Now, it's not just, or pick up movement just like that. Now, here's the thing. They also process this. This is like philosophical, but it's actually important. All right, just hang with me. We've done this experiment. It fascinates me, but like and if you want the details, if you want to go down that rabbit hole, I think it's awesome. But what you have to understand is that they perceive time twice as slow. In other words, they pick up movement twice as easily.
Well, okay, hold on. Well, how
slow motion to them? I know you won't believe me, but things happen in slow motion to them. They react twice as fast as we do. They see things twice as quick. They detect things twice as easy.
How do we know how deer perceive time? I got to know that.
All right, this is crazy. All right. Look up flicker fusion rate. If you want to go down that rabbit hole, look this up. But basically, back in the day when you had a TV before LEDs and all these other TVs came out, basically you're stringing together these still pictures on TV, and all TVs have to have what's called a flicker rate, and they had to put it above 60. And the reason they had to put it above 60 is because you and I also see things in still frames, and our brain refreshes that still image at 60 times per second and creates a holistic movement pattern. But that is not the same across animals. And so this is why like a dog actually has a higher flicker fusion rate. And back in the day when you had an old TV, a dog wouldn't watch TV with you because it looked like a bunch of still pictures to them. Okay, so all right. But that flicker fusion rate is also how fast you're refreshing time or movement or all of these things. So like, have you ever wondered how the hell a bat can catch a bug, or like how a bird is able to hit another bird in air? It's because they're like rapidly processing these images like super fast. Now that relates to their lifespan. Like if you look in the literature, there's only so many flicker and so many times you get that refresh, and then you're dead. So like short-lived animals refresh a lot, and long-lived animals don't. And if you want to go into the crazy world, it's like, yes, a fruit fly that lives 24 hours, even they perceive like an entire lifespan that in their own theoretical world is as long as ours.
Yeah.
So yes, you're picking that stuff up twice as fast.
So I read something recently about that. It might have had something to do with space travel or something, but it was like from a fruit fly's perspective on what it would see if you were going to smash it. And it was like a description of this hand coming down forever because that's their entire existence, even though to us it's 24 hours.
Yeah, it's crazy, but yeah, that's happening in absolute slow motion. So like they've done studies where they've looked at like, how does a bird catch a fly? Like that should amaze you to begin with, right? Flies move so fast to us. No, to a bird, that fly is going in slow motion. All right, and that's the same thing that's happening with deer. When you're moving and you think you're moving fast or you're moving subtly, that's slow for them. They have twice as long to pick it up, if that makes sense.
Sort of.
Well, it all comes back to this idea of like all they care about, their whole brain is wired simply to pick up motion. That's how they detect predators. You and I, we're not made to pick up motion. What we're made to do is discern objects. Like I see a person, I look at that person, I discern who they are. Deer don't care about that. They just want to have basically a scan of their environment and just be able to pick up something that's moving. That's what worries them. And given that, it also means that quick motions or jaggy motions, or you just trying to be more subtle with your movements, That's not subtle to a deer. That's not fast to a deer. So if you move, don't be surprised when they peg you.
Okay, this is going to maybe be way off here. Is this part of the reason why we figured out how to throw stuff to kill things? Because if we just took off after a deer, we're not built for it.
It's 100. We 100% all. If you look, all right, you want me to go into this, but if you look at like basically our perception, it's all about social interactions with each other, and a lot of our stuff, like our eyes aren't necessarily just made to be good predators, but also like the social interactions between us. And so we had to at some point become good at killing them without actually chasing them down and ambushing them, because we're nothing compared to a prey species that actually is hunted all the time.
Has anyone done any studies on, so we're talking whitetails, and we can go back through the last couple 100,000 years and figure out probably what was the major predators for whitetails and why this would evolve. Has anybody done anything like this with like axis deer from India and the tigers or any of the other deer subspecies?
So they've done it with fallow deer, and they're similar. You got to keep in mind that whitetail deer are pretty late evolutionarily. Like they're one of the more recent kind of additions to deer family. If you look at the more historic ones, or even something like fallows, it's still ancestrally held that it's all about detecting.
Yep. So this refresh rate and them sort of living in this, I don't know, maybe this is wrong, but like compared to how we perceive stuff, like a little bit of a slow-mo world where they're picking up stuff instantly. We think of it like, if you look at it from the perspective of what we're talking about, it's like, okay, if there's a tiger or a mountain lion or something crouched in the grass and that sucker takes off, the earlier detection system you have, the better chance you have to get away. And now we can take that as hunters and go, okay, well, just if I dumb this down, when I'm sitting in my tree stand and that deer's, approaching 50 yards away and I think that I'm out of its field of view and I stand up and that sucker catches me, it's over. I mean, it's why they jump an arrow, like you and I like literally like can't even see that arrow go. And yet they can hear and process that they're in danger and start the duck within a time frame of an arrow getting to them in 20 yards. I mean, just think about that. And it's because that is actually happening slower to them. Yeah. And that's an interesting example, because everybody, we say, oh, you're ducking the arrow or jumping the string. And all they're doing is just getting away from a perceived threat that they can perceive real fast. It's not like they're sitting there thinking an arrow just got shot at me. They heard a noise that alarmed them and they loaded up their legs to take off.
Bingo. It's just instinctual. It's like, okay, I didn't see it, but I heard it.
Yeah.
And their hearing isn't much different than ours. So, it's about identical. So, just some kind of spark, some sound that doesn't sound natural, time to haul off.
So their hearing is the same, but similar, but their reaction time is way faster.
Yep. That's exactly right.
How do hunters use that? Just don't move?
Well, it's nothing that hunters don't already know. If you're going to, get above them, right? If you look at how deer basically see their world, they're meant to look kind of down and scan the horizon straight ahead of them. They're not used to being hunted up. You get about 20 feet, 15, 20 feet up, you're out of their line of sight unless they're lifting their head. If you're going to move, always have something behind you. They have poor depth perception. So this is just basic hunter knowledge 101. Get your silhouette covered. If you're, that'll help them not see the movement. If you don't have a silhouette, if you're silhouetted at all, be really, really tight with your movement. Don't be surprised when they peg you there. It's basically like you hunt for a couple of years and everything that I'm saying. You know what I'm getting at?
I know exactly what you're getting at, man. Can we talk a little bit about the difference between them perceiving movement, on the ground around them versus above them? Because that's an important distinction.
Right. So they are anatomically made to perceive threats on the ground. Okay. Their biggest predators back in the day were some type of wolf and cougar type, combination, right? And so when we think about that, it really comes as no surprise that they have a hard time seeing up above them. And it's not just like they have a hard time seeing it, but actually their vision gets more blurry. If you and I look straight ahead of each other, actually on the periphery of our vision, it's quite blurry. And it's the same for deer, right? So they're looking straight ahead. And as you get further and further higher up in the trees, if you will, it's blurrier and blurrier. So you're able to camouflage in more and more. But again, remember that all these nice fine detail camouflage patterns, that nice fine detail that you're talking about doesn't mean crap to a deer that's 20, 30 yards away from you and already you're blurry. It's all blending of those colors. So you want to, if you're either got some good blobs going on or you don't. At that point, that's where it comes into. If you're one solid blob or you don't have a really strong camo pattern that has big differences in those shapes, then don't be surprised that they'll still trigger them to see you, because even though they're not made to see you, you're still in their field of view. If you have a couple decent camo patterns or a bunch of bigger macro blobs, if you will, you can get away with a lot.
Yeah. So, I mean, what you're saying and what you alluded to before with people, hunters with some experience definitely understand this. When you get up there and you're in a little tiny tree and you're silhouetted against a bright sky or, the sunset or whatever, if even something that had terrible vision would be able to see the movement there better.
1,000,000%. That's what they're going to key in on. It's all about taking the blob. I keep saying blob, but the figure that is yourself, and either hiding it behind something or moving ever so subtly that you don't cue them. But in the end, I can't stress enough the importance of covering your silhouette. That will break up the movement pattern because it'll basically, they have poor depth perception. It'll converge. That tree basically converges with you into one thing. Yeah. Does that make sense?
Yeah, absolutely. I mean, I set 90% of my stands to be behind the tree and shoot around it.
Yeah, those saddles, the saddle harnesses and all that, they make a really big difference in that. I remember, the first time I ever sat in a tower deer hunting, I kept getting pegged by deer. I was like, I'm covered. Why am I getting? And I realized real quick, instinctively when I got into the tower blind, I had put a bunch of twigs up behind me to stop my movement. And then, the deer were used to seeing nothing there. Yep. And so all of a sudden now freaked them out. It's all about keeping with your environment.
So I want to ask you about that then. So when we've talked about how they can see certain colors and what light position or what light is beneficial to them. We've talked about movement, but what about that deer when you're up in your stand, you don't move, it's not a deer you want to shoot, and it's just walking by, you feel like it's over, and that deer stops and looks right up at you and you haven't moved.
Right. That has everything to do with that you're not blending in with your background because your camo pattern doesn't. Remember, it's almost like a bright yellow color. You got to remember that all your camo patterns are basically looking some subtle variation of yellow. When you start to realize that, then you're not blending in with your brown tree. In fact, most camo patterns aren't blending in with their surroundings all that well. Just deer have really shitty vision.
Yep.
Right?
Yep.
So at that point, it's just they pegged you because you're sitting still silhouette against the tree.
Yeah. Well, is there an element to that of just, their life is condensed to, say a square mile is their home range and they know it real, real well, and something new? No?
Yeah, no, I mean, anyone that's ever hunted, out of a ground blind or something, they'll tell you all of a sudden, I know they can't see me yet. They're snorting all day at that ground blind. No doubt that there's something unique about it, but they have to be able to pick up that it's something unique about it. Ideally what a good pattern would do or a good set would do is you could sit up there and they wouldn't be able to tell that there's something new going on there. So it all comes back to, again, them being able to detect you is the problem, not that you're something new.
Yeah.
Does that make sense?
Oh, absolutely. What about the deer? What are deer doing when you get that old doe that comes in and she looks up at you and she stomps and does the head bob? What's she doing?
So it's she's actually trying to unsilhouette you or get depth perception from her environment. So like, I don't know if you ever see it, but when like squirrels jump trees, they'll move their head a bunch before they jump a tree. And that's, squirrels have the same thing as deer. They have a really good field of view because they don't want to get eaten by hawks and everything else. But that means you only get good depth perception when your eyes actually cross over each other. That's why you and I have excellent depth perception. Our field of view on both eyes crosses over for a majority of the view. Deer, squirrels, most prey animals don't have that. They'd rather have an expanded field of view, but not a lot of overlap between their two eyes. So they have terrible depth perception. So what they do to get that depth perception instead is roll that image over their eye by moving their head. And what they're doing is they're trying to get different images of the same kind of picture, if you will, and it enhances some kind of depth perception. So what they're trying to do is see you versus their background.
They almost have to like build a map of what they're looking at because of the way they're. Oh, that's interesting. So
in some ways, if you want to think of it so simple as like they're trying to make you a three-dimensional object from their two-dimensional world, but it's not that simple. But that's really kind of it.
I think it was in the study in the original study we were talking about that you did, where the blue light. Gosh, I think this was what you had written about when deer are spooked and they take off, they flip their tail up. And that's a very, we look at that and that's a white flag going through the woods, but to them, that's tied to their blue light sensitivity, right?
Yeah. So if you look at what they're sensitive to, that tail reflects a ton of blue. And so that tail, when it goes up, is visible even in the darkest of dark to deer. So yeah, it's a bright white tail to us, but to them, it's probably a bright blue tail or a very like, you know what I'm saying? And it's got and so when they throw it up there, it's an alert at any light condition. So it's reflecting exactly what they're most sensitive to.
So this, what makes me curious about that is a lot of people will take a deer decoy and they'll tie a little, paper towel or some kind of white flag to the ears and the tail.
Mm-hmm, mm-hmm.
But that's probably not reflecting the same light as a deer's actual tail, huh?
No, it's not. I mean, you're probably getting away more with, deer coming into it because they're curious and it's another deer and there's movement. I mean, there's a bunch going on there, but it's not, that doesn't necessarily have the same color as a deer tail would to them.
What's next, man? So you do this you've done, and you said you've done what, 4 studies on deer vision now?
Yeah, we've done 4 different studies on deer vision, looking at their color discrimination. So like things like, it's not just like, we want to know just how well they can pick out this color of green versus this color of yellow, things like that. The movement, the refresh rate, all of that. We're working with a bunch or some companies actually to deter deer vehicle collisions, like, trying to make a headlight that actually you and I see as a normal headlight, but deer can't see. That's the main application for a lot of this stuff. And then, spreading the word about thinking about how a deer actually perceives its world versus how you perceive its world and why those are so different and how you should kind of incorporate that into your hunting strategies is the other thing. But the research is basically more or less wrapped up. We know we've gone and been there and done that for almost all of it.
So what's next? Maybe just professionally, what are you like, man? I want to work on this.
So I pivoted completely, and I do a lot of work now I work with Mike Chamberlain on a lot of turkey stuff. I do a lot of duck work, and I do a lot of deer management stuff at like broader scale. So stuff with like working with state agencies to set regulations and stuff like that. So I've had my fill of all the deer physiology stuff, and I love to tinker with it. But professionally, I'm on to more of the like applied management behaviors of animals type stuff.
All right. What drives you the most nuts, knowing what you know about deer vision and deer biology? What drives you the most nuts that you hear just the average hunter say?
About deer biology, there's a couple things. I'll tell you what, the worst thing, the toughest thing as a biologist is the general skepticism that hunters have towards scientists and regulators. Sometimes that's warranted in the political world that we live in with decisions that are made, but oftentimes the people that are helping make decisions and inform science got into it for a reason. Is because we're obsessive hunters ourselves. Now, from a deer physiology and all this other stuff, all the science I've done, and what bothers me the most is two things. When I go out there and I see a state that's the Department of Transportation that's spending millions of dollars to put together deer deterrent stuff that simply won't work, that's frustrating and a waste of money. And then hunters that basically latch on to a specific brand of clothing that they think the camouflage is somehow superior than another one, when it's really all the same. And what you really just want to buy is a quality garment, not necessarily the camo pattern that's behind it.
Yeah. You want something that's actually going to keep you warm and have a nice weight to warmth ratio and allow you to draw your bow and move and stay out there in the cold and all that good stuff.
And we've moved. So, in the last 10 years, there's several really excellent camouflage brands that I don't care what color they are, what squares and circles they put together, but the quality of their clothing and the comfort that you have in the field is a game changer. And that's what we should be focusing on.
Mm-hmm. So I wanted to ask you that. You kind of just brought it up there. I kind of wanted to bring this full circle, to ask you if you were keeping deer from getting hit down there in Georgia by cars now, or is this is still, I'm guessing, a work in progress, huh?
So there's one study that followed up on our study. And all right, so you put together a headlight, right? And you say, okay, let's see if this will work. Let's put together a headlight and see if it'll lower deer vehicle collisions. Well, the way you do that is you've got to drive a car at deer going 55 miles an hour. And that's good luck with getting that through, your approvals. But hey, there's one group that did it, and they found they didn't actually change the headlights. They instead did something which was interesting. They took a light and actually reversed it and actually flashed it onto the car so that you wouldn't see the light, but it basically puts a glow of a vehicle around while they were approaching deer, and they found that it decreased deer vehicle collision. So there's ongoing work there, but it's a slow process. Anything that you ever want to tinker, not just with the science, but the actual, it's a federal level regulation of let's change headlights. That's going to be like a 30-year career goal.
Well, sure. I mean, there's a ton of money at stake there, which, I guess could go either way with it. But so when you talk about that, and you say, oh, okay, we're working on a headlight with certain colors that, humans perceive as bright as we need to see them, but deer don't see that. Why do you want deer to not see that light?
Oh, yeah. So it's because the deer in the headlight look is a real thing. So they're so sensitive to light. We talked about that mirror reflectance and stuff like that. They're so sensitive to light at night, right? So like I said, they're reflecting light like crazy. All of a sudden, a bright light that's combined literally blinds them. It shuts down their photoreceptors. It's not like they just, they don't know what's behind the car. It's that, they don't know what's behind those lights. That's no doubt. But they're literally standing still because they're temporarily blinded. They have no clue what's going on. So if you can get something that they're less sensitive to, you're less likely to blind them. They can then perceive that a car is coming at them 60 miles an hour and get out of the way. It's that simple.
Yeah. And this would be something that would, if it worked, would reduce, deer vehicle collisions by, a certain degree, right? It's not going to fix all of them because they're going to run out on the roads.
Most of the deer that get hit, or I won't say most, a proportion of the deer that get hit are simply rutting bucks that are running around and are just got one thing on their mind, and it's not even a matter of them being blinded. They're going to run straight into your car anyway. Yeah, it's not the solve all, but it's all about small mitigation efforts. They found that basically the best thing to deter deer vehicle collisions is simply put up a sign that says "Drive slow, deer crossing," and flash it in front of people. It's a human problem more than it is a deer problem oftentimes. But our hope is that this can make a small incremental change to a pretty big problem.
Yeah, I mean, you look at. The driver awareness is a huge component. How close the woods are, the cover is to the road, or how much of a ditch you have to see them. There's a lot of things going on there. But what an interesting! I just think that's a cool opportunity for somebody like you, who's a diehard bow hunter, to suddenly get that professional opportunity to dig into a problem like that has all these ancillary potential discoveries beyond a pretty admirable goal of keeping people from hitting deer.
In general, I've lived the dream ever since I got in this field. I'm an obsessive hunter, and everything I do, I won't lie, I relate it to how I'm hunting and how others are hunting and all of that. But to be able to turn some of the information that we're getting and apply it to real world issues that are much bigger than just, can I kill a deer more efficiently? It's very, very satisfying. It's a good feeling. So
if you had, if there was unlimited funding and no real oversight, you're just free, man. This is, you just do your thing. What would you study with deer? What's one thing that you're like, man, I want to learn this? Or do you feel like we're kind of tapped out on deer?
You want my real opinion?
Absolutely.
I think we're not tapped out on deer. CWD and questions regarding CWD are going to be ever present and ever important. And how CWD interacts with predation, hunting, all these other things that are killing deer, super important. To me, the more pressing issue, or what I'm more and more increasingly interested in, is how are we going to aggregate and use that data to actually make a more robust management approach, besides just kind of being like, okay, coyotes kill deer. What does that mean? Should we kill 2 less does in the bag limit? That sounds right. And just go with it. Instead, it's like, how are we going to integrate all of this science into some kind of holistic management practice that responds to conditions on the ground quickly? That's where I think science is going to head, so that it's transparent, clear, and quick to the actual population needs at a local level. That's probably where we're at with deer management.
Yeah, that's.
And by the way, that was sarcastic about people saying like, oh yeah, just 2 less does, but more or less, No,
I get it. I mean, that is one of the things. I was just talking to a buddy of mine who's a conservation officer here in Minnesota, and so he deals with a wide range of questions, and he deals with the DNR as far as their biologists and their science research, and then he deals with the end user, the wide variance of hunters and fishermen out there. And one of the things that we just kind of got to talking about is how easy it is as a hunter to be like, okay, I look at deer management through my 40 acres that I've hunted because my grandpa owns it, and that's what I care about. And then you look at, just take Minnesota as an example, a state that's pretty big, really diverse habitat wise and human population wise and deer population wise and predator wise. And then you start looking at an animal like the whitetail and how there's $1 billion industry built around this animal, and it's one of the most interactive species that we have out there. And so as far as like the science around it and what we have to learn, this is a complicated situation because we are so involved with them, and they play so well with man in so many different ways. It's not, it's not quite as simple as an isolated population of some animal, largely unaffected by man, I guess I'd say.
Sure. And in the deer ecology world, a lot of it is we're building off of things that have already been done for many years. Each study is a logical stepwise progress towards a better knowledge of how deer are being affected by multiple processes. And back in the day, it was like, okay, how does this affect deer? How does this affect deer? And then we started to do how do this and this combined affect deer. And now we're like 3, 4, 5 layers deep in it. And the whole goal here is, nowadays in a world of social media and constant information at your fingertips, how do we be as transparent with the science as possible? And how do we be as rapidly responding to issues as possible? And that is where I think deer management, it's already going there. I mean, I'm not saying anything new. I'm not saying anything surprising, but that's where we're heading. Is the process getting there might be painful because it takes a lot to get there, but that's where it's got to go.
Yeah. And are you so emphatic about that? Because without, support from the hunting population, this is a bitch.
Yeah. It's all about, I think I told you from the beginning is, or when you said like, what bothers me, it's the idea that the hunters don't buy into what we're telling them. Listen, I grew up in New York. I hunt Pennsylvania. I know what it's like to have, I've heard a lot of different people being skeptical about decisions that are made. And so to me, I'm only emphatic about it because I know these people and I know the good they're trying to do. And I know where the message you can see where the message gets lost. And so to me, the idea is in a day where data can be at your fingertips. I want you to see that data. I want you to understand why we're doing what we're doing. It just makes sense to me. So that's where you give me unlimited money. It's promoting transparency. It's promoting data collection, and it's promoting sound management. It's not necessarily going to another spot to do a different type of iteration of the deer vision study, if that makes sense.
Yeah. There has historically been a pretty significant disconnect between a lot of state game agencies and the end user and what's really going on there. And that has led to a lot of problems.
Yeah, well, it comes back to a bunch of different things, right? One is messaging, but it also comes back to scale of management. You talked about the guy in his 40 acres. What that guy on his 40 acres and me on my 40 acres, what we see is a microcosm of something that a deer biologist isn't imagining for. They're imagining at best, a region. That's where we all want to head. A lot of states have that already, but theoretically we make that region as small as possible so that the two match up. But oftentimes it's so misaligned. You've got somebody that's managing and doing their stuff well in an otherwise pretty desolate landscape for deer, and they have to suffer those consequences. You see what I'm saying? Or vice versa, somebody's not doing the right thing in a place that's got a pretty liberal season. So in the end, decreasing the scale of our management and responsiveness, it all comes back to sound data collection. And honestly, that is not something that's something everybody wants, but time, money, effort, there's only so much you can possibly do. Yeah. So that's why I say it with a unlimited budget part.
All right, man. Last question for you here. So as a passionate hunter and a deer lover and a guy who's involved in the science, what's one thing that pops out into your mind that you've learned through your research or somebody else's research that you've been studying up on where you're like, you know what, I'm taking that into the field with me and I'm never going to forget that?
How sensitive deer are, all animals are to hunting pressure. It's not, I used to know like, okay, well, I'll just hunt this spot, my favorite spot, with the right wind conditions, with this, I can hunt it when I want. No, there's like a legacy effect of you going in and just being in that area. Like I completely changed how I access my properties. I only go in from the edges. I minimize disturbance, not just on a good wind, but like I take as few freaking steps as possible. Like, and because the science has clearly shown that just like your presence in that area is a tangible thing that deer can pick up on, and they'll start to avoid it really quickly. And that's probably why so many bucks are shot during the rut, is they give up that that awareness to chase does around, plus being more active.
Well, yeah. And I love that you said that, because I kind of look at this like it's really easy to spend somebody else's money, right? Like it's really easy to be like, Jeff Bezos should pay this much in taxes, or he should spend this much or give this much to charity, but we don't look at ourselves the same way. Typically, we do the same thing with hunting pressure, right? Like we're always like, oh, this asshole came in and he walks around at first and last light and scares them all away. But we don't think about the thing we can control, which is our pressure in a situation, because we're so biased toward what we want to do. And like you said, well, if I go in here and the wind's right, it's all good.
Yeah, it's crazy. Like, just even with the stuff we do with ducks and turkeys and what we see with deer and just about everything. I mean, animals respond to hunters, and it's because I now realize through common sense, like they have to. There's no other animal that they can interact with from 80 yards away and be killed.
Yeah.
Like, you know what I'm saying? Like they've got to be on it immediately. And so, them turning nocturnal, them shifting their patterns, it's immediate, it's quick, it's lasting. And so it completely changes how I approach almost every situation. I'm very strategic in where I go. I'm very strategic in how I approach it. I'm strategic in if I have to leave when things go differently. And I've seen, I harvest more deer or bigger deer because of it, I think.
For sure, man. Such good stuff. I really appreciate you coming on the podcast. This was a blast, man.
Yeah, man. I appreciate you having me. Thanks again.
That's it for this week, folks. Be sure to tune in next week for some more whitetail goodness. This has been Wired to Hunt, and I'm your guest host, Tony Peterson. As always, thank you so much for listening. And if you're looking for more whitetail content, be sure to check out themeateater.com/wired to see a pile of new articles each week by Mark, myself, and a whole slew of whitetail addicts, or head on over to our Wired to Hunt YouTube channel to view the weekly content we put up.